It's time for the final part of this tutorial. I hope you enjoyed it so far. And the final part is creating a JSON document. And with JSON, even Embarcadero, I think they had 3 tries by now. If you count FireDAC being able to generate JSON as well, 4 tries. And you have so many opportunities to create JSON documents now with Delphi that it has become, in all honesty, a little bit of a mess. Which class you use, which value type you use. There have been many different approaches. The doc wiki is a great resource in this case because the doc wiki compares all the different approaches. So if we go to the doc wiki, Delphi, JSON, then we'll look here at JSON, and here's the different JSON frameworks, and here's all the different means that Delphi provides. These are just 3, how to handle JSON, and then here are the different units. And this one doesn't even mention, I think, no it doesn't, this is just for system JSON, but there's also a REST framework, DataSnap, that has JSON, FireDAC has JSON, so there's so many things, but for me, one essential thing is missing that does give us a clear instruction how to convert objects that we have or objects that contain lists of other objects to JSON and vice versa. It's the so-called serialization and deserialization. The DataSnap functionality was great, but it's not as flexible as what we need for this. And instead of relying on any of the solutions that are bundled with Delphi, we pick a solution that is freely available on GitHub, and it uses the JSON classes that are part of Delphi. Alternatively, if you want to write a cross-platform solution for your application, I wholeheartedly would like to recommend the FNC4 JSON approach from TMS, because TMS also built JSON persistence as part of their FNC core, which allows you to quickly persist objects into JSON documents. But for this one, I wanted to use the step-by-step approach without stepping into the FNC library. There's videos for that. There's also great blog posts written by team member Peter. He has written lots and lots of content how to persist JSON documents and also how to create your objects based on JSON documents. So both is available. Look at the TMS website for these if you're interested in using it cross-platform with the FNC toolset. I instead focused on a library that's called Neon that allows you to serialize Delphi objects quickly. So this is Delphi Neon, and it's available on GitHub. It's written by Paolo Rossi, a fellow MVP inside of the Delphi community, and this library comes with a great demo that allows you to configure everything in a UI to test the library, what it does, how it serializes. It can serialize and deserialize whole data sets if you wanted to. But we're going to use it to serialize a data structure that we're going to build using so-called data transfer objects that are specifically designed to create a JSON document. And that is actually what I wanted to start with today. If we look at the UTypes unit, these are types, object types, that I have implemented based on the data that is in our database, and that is supposed to go into the JSON document. For example, let's start on the top. We have a book, and a book has an ID, a publication date, a title, a subtitle, and a cover image, and a list of editions. And the editions have a name, an Amazon ID, and a list of stores. And the stores have an ID, a name, a domain, and so on. That is literally the idea behind object-relational mapping, that you work with classes, with objects, and that these classes are at the same time also inside of your database, that you don't have to take this additional step anymore, that you have objects that are the same as your database content, so to speak. And this shows you, because we don't use Aurelius or any other object relational mapper, we now have to create classes and then transfer the data from our datasets, from our queries, into those objects. And if we had worked with an object relational mapper, our objects would already contain the data from our data. However, this is only the half-truth, to be honest with you. Because even in the book that I wrote about object relational mapping, you still might want to make subtle changes to the JSON document and don't want to transfer all the information from your database into the JSON document. And at that point, you once again have your so-called entity classes that store the information that is inside of your database. And you still have data transfer objects, which take a subset or prepare the information differently for your API. Still, you're significantly more efficient being able to use an ORM in this case, because you can select the data quicker, you can prepare the information quicker using objects and methods and object-oriented programming instead of jumping back and forth between the T-dataset world and the object world each time. So at this point, you kind of realize maybe it's worth looking into TMS Aurelius after all. This is why I wrote this part in here. It's still pretty straightforward. At this point, because it's just something that I wrote quickly, that I needed within a day, and this application will carry me through the next couple of years for the purpose that I needed it to get done. So it doesn't really make sense to upgrade it to object relational mapping for me, because I also don't think I'll ever use a different database than SQLite, so that will also not be a consideration. And the SQL statements are all set and they don't grow, and I'm fine with my SQL statements as I have them. They're not too complex that I say object relational mapping could be an advantage, so I don't have to deal with them. However, the transfer from the dataset to the objects is already something that feels a little bit cumbersome, where you realize like, maybe I should give object relational mapping a shot. Let's look at the implementation of the whole thing. So first of all, a JSON document, or the JSON document that we create for this, has two major properties: a list of stores and a list of books in our case. We looked at this way at the beginning of this video series. The stores are a list of store objects. Very easy. So we have the store DTO here. So that's the list of our stores. It has an ID, a name, a domain, and country ISO. Done. Very easy. Whereas the books themselves have an object structure in themselves. Books have editions carry a list of stores, whereas I made one significant change. The stores are not repeating the store over and over again. I would literally have the whole thing in there. Instead, I just list the ID of the stores, and then I have to look up the ID on the client side in the list of stores. That made more sense to me than repeating the stores over and over again. So I just list the IDs of stores that it's available in. I didn't add the difficulty only to list the stores that it is not available in, because it's just like, if you look at the file in the notepad here, you see with the formatting, right now it's not formatted yet, so format JSON right here. So here, this is the list of stores. I mean, I could have just listed the ones that it's not available in, so the list of stores would be empty, but like these couple of numbers don't really matter too much that they have been transferred or not. So with that being said, you can literally see that the structure of the store DTO that you see here in the source code is matched directly. ID, name, domain, country, ISO. The major difference is that, if I go back to that it's lowercase instead of uppercase, and this is something I configure, and this is what I said, like we don't have in Delphi right now a proper tool that allows us this kind of flexibility. I said, hey, I want my property names to be camel case, which is far more common than the Pascal standard to name variables. So in this case, instead of uppercase ID and uppercase name, we start with a lowercase, and as soon as there's another uppercase, like here, ISO, it is capitalized again. And this is what is used, for example, in C# by default, and is used by Swift by default. So this gives us way more compatibility with other programming languages. And I even give the example in the book that this kind of thinking is very, very beneficial with regards to which clients want to use your API in the future. So that is pretty straightforward. Where we need to think a little bit more, again, is the cover image, because this is a so-called base64 encoding. Base64 encoding is used to encode binary information and only use characters that you could type on your keyboard, so to speak. So it's textual information for binary information. It blows it up a little bit by about 35% on average. So that's why the images should be small, or you should store the reference to the file name or the URL instead of embedding the whole picture. The date is also being converted to the ISO standard, how dates are supposedly formatted in JSON. Again, these are all recommendations. I think there still isn't like some sort of mandate that you have to encode your dates like this. This is just very popular. For example, if you put this into, try to load this in Swift, which is the Apple language, which is used for iPhone, iPad, macOS. If you put this date into JSON and load it in those languages, it immediately understands, oh, okay, this is the date that you're looking for. If you pick your own custom format, you might have to do some formatting on the client side as well without being able to use their standard functionality. So this works great. And the same goes for the base64 encoding. Every client needs to be able to decode this. And for the web client that we have, this is not a good format to have. Instead, you would pick something like a data URL, and I'll show you that when we look at the web client later on. So this is a lot of information, and then the data URL, by the way, I included the property inside of the JSON already because I reused the same class in the web client and inside of the VCL client. So if this will stay empty for the VCL client because only the web client will use this internally. So I just kept it in there. And then here is the description in Markdown. And then the list of editions. Each edition, again, has its properties and the array. Or did I make it a list? Let me see if it's an array or a list. A list of integers. So a list of integers is also handled correctly by the serialization that I use. And as said, we're going to use the Neon library, which makes it very, very simple. So first you configure how the serialization is supposed to take place. And they use an interface which you can create, and then you can literally, by duck typing, you can say tneon configuration.default, which starts with the defaults. Set member case. This is what I just said. Like here it is snake case. I use camel case. Set members properties. Okay, we want to serialize the properties of a class. Then set ignore field prefix means the F in the beginning of the fields. If you're serializing properties, you don't even have to, think about it. And then set visibility, which of the properties, what visibility should they have if they get serialized. So if you only serialize the published ones, and this serializes the public ones and the published ones. So, and you can even write your own serializers for the library. And how it's being done, very, very simple. You basically call object to JSON with your object, and then you get a string in return. And that string you can then basically, or here in this case, it's a JSON value, which you can easily convert into a string using the print method from tneon. But that's what I show you now. So looking at the implementation for the JSON, again, I added it to the data module, not to its own file, save to JSON right here. In this case, we get a file name. We don't get a folder because it's only one file. We create the payload. The payload is what we've looked at. Just as a reminder, it's the class that stores the stores and the books, the two lists. So I create that class. And from there, I iterate all the stores and add the stores. And this is what I said, like, this is what gets tedious. You know, you create a store with a store DTO, you transfer all the data from your data set into the store object, add the store to the stored list in your payload, and do that each time for each store. Done. So at this point, payload contains all the stores, and you're done. You do the same for the books. You transfer the book information, and then if you have the book, you go into the editions and iterate all the editions. However, right here, query editions first, and then the same thing. And then you do the same thing for the available stores. You only list the ones where the book is available in, and then you add the book finally to the payload of all the books. And then you go to the next book record. That's how you fill one instance of tpayload. It contains a list of all books and a list of all stores. One thing, how do we generate the images? So here, we take rather big images. I take 500 pixel big images because I want to show this on an iPhone. And if this goes like this image here, in order for it to be high resolution, it has to be bigger and not like just like 50 pixels or something. I want a sharp image. So for that to happen, I use 500 pixels for the width. And I use the high quality resampling. And what I also do is I change it to JPEG. So in order to decode the JPEG image, I write it as a JPEG image. And with that said, it also shows us how easily we can transfer between different file formats, resample, and then also affect the parameters of this file. Like basically reduce the compression quality to 80, so 100 would be no compression. 80 is still rather good if you have 500 pixels available, so it's still going to be nice and sharp. And then I write that into the cover field of the book cover. And if I look at the type that I defined, then you'll understand why that's possible. If you look at tbook DTO, it's a memory stream. So I literally write into a stream at that point. And the serialization that I use will be able to convert this memory stream to base 64. So all I have left to do is I have to configure the Neon library, member camel case, as I said, and then I want only the properties, only the ones that are published. Again, we look at our view types, published properties, right? Only those and only the properties. And then set pretty print false. I don't want any additional spaces or anything. I just want it like in the file. Non-human readable. Human readability is not the focus here. It just has to be all the information in there. And then I literally say ljson is object to JSON. The payload is this object, and it automatically picks up all the lists and all that kind of stuff. It uses this configuration. And then I can call tfile write all text. It's a rather new method. It simply creates a text file. This is the file name, and the content is ljson toString, because ljson is a JSON value, and I can simply say toString, and then you get the string of the JSON document. That's it. So you write a string into a file. That's how simple it is. And then you free the payload, and you're done. You don't need to free any of this because these are all interfaces. And ljson is not an interface. So what I should do here, I should free this. Good that I picked that up. So ljson is not an interface. It is a tJSON value, which is something I explained at the very beginning of this video. Neon uses the Delphi-specific JSON classes to serialize and deserialize, which is pretty cool. So you don't have to learn different JSON classes for that. It just adds the serialization on top that you can write your classes, or objects, I should say, quickly as JSON document. And then you're good to go. With that, you have your JSON document created. And with the JSON document, we're now ready to build the web application, or if you so desire, build different clients in different programming languages in order to open up your data to the world. Obviously, I could have written this iPhone application also with FireMonkey, but in this case, I was just more efficient writing it in Swift, because Swift has excellent JSON handling that you can just basically transfer JSON documents right into an object structure. And another thing, Swift UI is a declarative, might not sound familiar to you, but has a declarative way to define your user interface. So this user interface is literally like five lines of code, and everything just comes together pretty quickly, which in this case, for this particular use case, is the more efficient way to create the list that I wanted to show here, instead of building it with FireMonkey.